Hey guys, so in class we did an example of powers of sines and cosines. And so what about powers of tangents and secants? So for these problems, oftentimes you'll get either that both are even or both are odd. It's very rare that you'll get one where one is odd and one is even for tangents and secants. For cosines and sines, yes, but for tangents and secants, you may get they're both odd or they're both even. So in this case, we have they're both even. So when you have for even powers, what we're going to do is the same idea as splitting as we did with sines and cosines. We're going to split off a secant square from the secant term. And that's, you can kind of probably guess because we're going to want secant square to be part of our du. And so we're going to have, so I'm going to split it off. So I'm going to have tangent square of x times secant to the fourth is secant squared times secant square. So that's the one that I'm splitting off. So I'm splitting off a secant square. So that means I'm going to want this to be part of my du. When I say part, again, is it could be off by a negative or by a constant, depending on what my main function here ends up being. So now, which one did I change? I split it off from secant to the fourth, which means is this one, right? So this is the one that was changed. So this is the one that we are going to use a Pythagorean identity on. So we're going to use the other one, the Pythagorean identity for secant and tangent. And if you don't remember them, like I always remember that sine square x plus cosine square x equals 1, right? So if I want to get secant, secant is 1 over cosine, so I'm going to divide everything by cosine. Well, cosine squared. Or I can think of, well, I want to get tangent. So now we can write our identity is really sine over cosine, that's tangent square. Cosine square over cosine square is 1, and 1 over cosine square is secant square. And so now I know I'm going to use this Pythagorean identity to change. So I know secant square is tangent square plus 1. So my integral becomes, with this changes, the integral of tangent square x times secant square x, I'm just going to rewrite it, times secant square x dx becomes the integral of tangent square x times, I'm changing my secant square, right? This one with this identity. So secant square is tangent square plus 1 times the one that split off, the secant square x that we split off from the beginning, dx. And now we're going to let u be tangent because the derivative of tangent is secant square. So let u equals tangent x, du equals secant square x dx. And so with this substitution, I get to change this integral into u as tangent. So tangent square will be u squared times u squared plus 1. And secant square x dx, that's du. And now I can simplify it. Remember, when you have a product, you can't integrate piece by piece. Only if this u squared wasn't there, then sure, I can use the general power rule. But I have this product here, so we have to distribute. So I have u to the fourth plus u squared du. And now we can integrate those. Once you integrate, you don't need the integral symbol anymore. So this will be u to the fifth over 5 plus u cubed over 3 plus c. And put it back in terms of x. What was u? U was tangent of x. So let's substitute it back in. So then this will be tangent to the fifth x over 5 plus tangent cube x over 3 plus c. If you want to get a common denominator and factor out a tangent cube, you can. So a super simplified version of this would be, common denominator will be 15, right? So this will be 3 tangent to the 5th x over 15 plus 5 tangent cube x over 15 plus c. And now factor out the 1 over 15 and the tangent cube. You can take out the smallest one. And so you'll be left with what? 3 tangent square x plus 5. That's not necessary, just in case you see something like this on WebAssign. I want you to be aware of what they did. But if you stopped here, this will be a perfectly acceptable answer on a quiz or a test. Okay, so another example, what if they're odd powers? So say I have the integral of tangent to the 5th x times secant cube x dx, right? So when they're odd powers, so if they're both even powers, we split off a secant square. When they're both odd, what we're gonna do, and this one's kind of tricky, we're gonna split off one from each. So we're gonna split one tangent, and we're gonna split one secant. And you'll see why. It's kind of clever once you see it. So when I split one off, I'm left with tangent to the 4th x. Split one off, I'm left with secant square x. And the ones that I split are, I have a secant x that I split off from the secant cube, and a tangent x that I split off from the tangent to the 5th dx. And what do you notice? Okay, the things that I split off are derivatives of other things. So I want this to be my du. So ask yourself, what function has a derivative of secant tangent? And that will be secant, right? So I want u to be secant. And knowing this lets me know which one I need to change. If I want u to be secant, I already have a secant square there, so I'm not going to change that. So that means I want to change tangent. And we're going to use the same identity that we used up here. Tangent squared will be equal to secant squared minus 1. So I can use this identity for tangent. So tangent square x is secant square x minus 1. I subtract 1 from both sides. So change using tangent square x equals secant square x minus 1. So our integral is going to become, so tangent to the 4th is tangent squared times secant square x times secant x tangent x. I'm just kind of rewriting. Since I know I need to change tangent to the 4th using tangent square, I want to get my hands on a tangent square. So that's why I rewrote tangent to the 4th as tangent square square. You could have also written that this is tangent square times tangent square. Those are the same thing. So this will become, what did we say? Tangent square is secant square minus 1. So secant square minus 1 square times secant square times secant x tangent x. You can keep simplifying here if you want, or you can make your u substitution right away. Right, let u equal, what did we say we want? We want u to be secant x. Then du is secant x tangent x. And now I can make my substitution. I like to simplify these crazy things once I've made my substitution because it's easier with u's than it is with the trig functions. So this will become u is secant, so secant square will be u squared, so I have u squared minus 1 squared times u is secant, so secant square is u squared times secant x tangent x, that's my du, so times du. And how do I integrate this guy? Let's multiply it all out. Remember, we can't integrate part by part when we have a product, so we have to And I can't bring this u square in because this is square first. Order of operations, right? Do parentheses first. I can't combine those. After parentheses, exponent. So I need to do that exponent before I can do that multiplication. So we're still using our order of operations here. Right? Parentheses, exponents, multiplication or division, and then addition or subtraction. So I can't multiply this u squared without doing the exponent first. So let's use that exponent. So u squared minus 1 squared means u squared minus 1 times u squared minus 1. FOIL it out. I'm going to have u to the fourth minus 2u squared plus 1 times u squared du. Right? So that u squared is still here. Now I don't have any exponents, so now I can bring it in. So it's u to the sixth minus 2u to the fourth plus u squared du, and now we can integrate it. So u to the seventh over 7th minus 2u to the fifth over 5 plus u cubed over 3 plus c. And what was u? U was secant x. So let's put it in. So this will become secant to the 7th x over 7 minus 2 secant to the 5th x over 5 plus secant cube x over 3 plus c. If you want to get fancy like we did before, get a common denominator and factor out the smallest, which in this case will be secant cube, you can do that, but you can also just end here and be done. All right, so those are the ones that you'll see the most. So either powers of sines and cosines, which with those, as we did in class, you use if they're odd, you split the odd one. If they're even, you use the half angle formulas. If you have powers of tangents and secants, either they're both going to be even, which then you split off a secant square, or they're both going to be odd. If they're both odd, you split one from each of them. The thing that's making them odd, you split one off, and that becomes your du. So I hope that this video helps in getting you through your homework or getting your homework started.